Okay, this is an acceptance sampling question taken from an SX06 paper, June 10, question 4. Temperature to do with components, and the components fail to work if the temperature gets too high. Samples of 10 components are taken, and those components can be assumed to be normally distributed with a standard deviation of 3.1. The component fails to work if the temperature exceeds 93, and in the first one we're asked to calculate the percentage of that happening if the mean of those is 91. So I've drawn a diagram here, normal distribution curve where 91 is the mean, 93 is the x value that we want to find the probability of it exceeding. I've used a standardized approach here, which gives me an answer of 0.0207 using z values, but far more likely is that you're going to use the graphics calculator. I'm going to use the NCD function, which I've already keyed in here. 93 is my lower tail value, 9999 is my infinitely high value. The standard error here is going to be 3.1 divided by the square root of 10, and the mean value is 91. And if I do that again, you can see I get my value of 0.0207 to 3 significant figures. For the second part of the question, really similar. This time the value is 94. So if the component fails to work at temperatures which exceed 93, if the mean then is 94, we're expecting far more of the components to fail. So I would do exactly the same again. I'm going to key in NCD. This time my lower tail value is 93. Actually, it's very similar to the one above. 9999 is the upper tail value. 3.1 divided by the square root of 10 I can enter, and I can put down here for my new mean 94. Now I could have done this actually by simply just going back up and changing 94 there, but there's my value of 0.8461. The second part of the question actually is quite a little bit more tricky perhaps, because it goes back to destandardizing. It can be done on the graphics calculator, but this is one that I choose to do in the tables. So for part B, the company decides to redesign the plan, and it now requires that the probability of rejecting a batch when the mean temperature at which the components fail to work is 94 degrees C should be less than 10%. The company also decides to reduce the sample size to 8. The batch will be accepted if the sample mean exceeds x degrees C, and we need to find out what x degrees C is. Now, what I've done here is I've drawn another normal distribution curve. So 90% of these are going to exceed a value. Well, 90% exceeding that value, I've got this value from table 4 of the formula book. Now the formula book obviously works for the values up to the value. So if we look at 0.9 here, we get 1.2816, and by symmetry 90% will therefore exceed negative 1.2816, which we've got here. Now that's equivalent to, when we standardize, x minus 94 over 3.1 over root 8. So the probability that z exceeds that is equivalent to z exceeding this. So we can then equate these two. If we then rearrange, and this is quite heavily algebraic, we multiply first of all both sides by 3.1 divided by root 8, and that's what that value is there, and that gives me minus 1.40465. If I then add 94 to both sides, the value that must be exceeded is 92.595 degrees C, or 92.6 to 3 significant figures. That's a destandardizing question, effectively, and the other time that you would have encountered that is in S1 papers, right at the start of the course. The final part of the question simply asks us to explain in the context of the question what a type 1 error is, and in this case a type 1 error is to reject a batch as being below quality when in fact they were acceptable.